right, well, we are reviewing for your exam in the next lesson. Also, don't forget, notebooks are due tomorrow, so make sure you have those notebooks ready to go. Trust you spent the weekend getting those ready. Also spent the weekend studying over some things that we had reviewed in the last lesson, some facts, some terminology that we need to know. Today, we're going to start by reviewing over some constructions that you'll need to be able to do for the exam. There will be 2 of these memorized constructions on the exam. You'll have to guess which 2, or just be ready for all of them. And then there'll be 1 unmemorized construction that you'll have to complete. Obviously, we can't go over that one, and going over a different one probably wouldn't really help a whole lot, so we're not going to bother. As long as you know your memorized constructions, you should be good. The first memorized construction for this section was to bisect an arc. So if you would on your paper, go ahead and make an arc. Now again, on the exam, if this were the construction, one of the constructions there, the arc would already be printed on the paper for you. You would not see the center point for this particular construction. What would we do if we wanted to bisect this arc? What would we need to do first? Kendall?
You would draw a chord connecting the ends of the arc.
And we just want to start by drawing a chord connecting the endpoints of the arc. Go ahead and do that. I say that is not the right homework, but that's for science class, isn't it? I didn't learn all lesson too. And once we've drawn this chord, what would we need to do next? Audrey?
Go to one endpoint and open it and below.
Okay, you said open the compass how much?
More than half.
More than half the length of this. Essentially, what are we doing here, Audrey? Good, we're constructing a perpendicular bisector. So we're going to go to the other endpoint and do the same thing, right? So construct a perpendicular bisector. And of course, once we've made the arcs above and below, simply connect the dots. And questions, comments on this construction?
Extend the line.
Extend the line?
No, the one you just drew.
Oh, this one, why?
Because it's not bisected.
Yeah, my line, my perpendicular bisector didn't actually bisect the arc yet. There we go. Now it bisected the arc. And that would technically be acceptable.
Yeah.
You don't have to have the whole line. That would be easier to do it that way, right? It'd be easier just to start at the top. Just make sure it bisects through the arc. Questions on this? All right, another construction we had was to construct a line parallel to another line. So if you would, go ahead and draw a line, maybe going a little bit at an upward angle, and then pick a point above the line. How would I construct a parallel to this line through this point? And let's go to Genesis. What do we need to do first?
Put the point of the compass on this point, given point,
Okay.
and extend the line of the compass more than,
Like this?
yeah.
Okay. I feel like we're constructing a perpendicular here. I said parallel.
Oh.
A parallel. Anytime we have parallel lines, Genesis, we always use a backtrack. When we think parallel lines, the claim, response, and a proof is equal angles. But those equal angles can only be formed if there is a blank with the parallel lines.
Angle?
Yeah, what would form these angles? Obviously the parallel lines and called a helper class transversal. That's the key. So we're actually going to start by drawing the transversal here. Start with a transversal. Remember, the transversal doesn't have to go very far through the line, but it should extend beyond the point a fair bit. Genesis, in drawing this transversal, I've now created an angle that if I could get an equal angle to this, I'd have parallel lines, correct? So thinking through that thought, now what? Let's go and copy the angle. So again, that's construction 3 where we make the arc. And then where do I want to copy to?
On the other side.
On the other side of the point up here, right? So we make another arc that looks just like the one we just made here. Right? Then of course we will measure the arc that we just made. And then here, of course, we'll want to start the point of the compass on the line so we can measure down across the arc. And then to finish, we simply will connect the dots. There we go. So again, transversal is the first key step to accomplishing our objective.
There's another way to do this though, right?
You could do a double perpendicular method. It would take longer, so that's why I didn't initially stop Genesis, because technically we could have made a perpendicular Genesis, as long as we extend the perpendicular higher and then made a second perpendicular coming off of it. Just takes more time, and on an exam when you're already a little bit tight on time because it's a little bit of a longer test, maybe a quicker way would be this way, but it wouldn't be wrong to your point to do the other.
If you feel more confident with the other way, you should do it.
As long as you can go quickly through it, yep. All right, let's go ahead and draw a line segment, and if we would, let's go ahead and call this line segment EJ, and we want to chop EJ into 3 equal pieces. That is to say, we want to trisect EJ. What would I need to do in order to trisect EJ? Well, take him to a magic show, and all right, Ethan seems a little sensitive about this construction. I'm not entirely sure why. Ethan, what do we need to do here?
Draw a line coming off E.
All right, draw a long line coming off of E at an angle. Again, the longer the better. Make it nice and long. All right, then what? Bisect the angle. I don't think that's going to work too well to chop EJ into 3 pieces. Divide, trisect EJ. That sounds so much better.
This is scary.
Quentin would be glad to help with this construction if
I know he would.
Quentin, help us. What do we need to do?
Your compass out.
Which compass out?
Open
Sharp point of the compass.
Open the compass foot. Point the compass on where EJ or
E is, yeah.
Yeah, and just make arcs.
All right, just make arcs. Now, what we want to do is we want to try to make the arcs as big as we can without going over. So, like if I open it this much, I don't think I can fit 3 of these. But I think I could probably fit 3 of these arcs here. So 1, 2, I might not. Ooh, just made it. Okay. So again, it's just a reasonable amount, something that looks like it'll fit. And I like to number these points, 1, 2, and 3. I also often like to scribble off extra here. Ethan, does that jog your memory here? All right, so let's have you take over again.
Would you put the point of compass on 3?
Well, we don't really need to put the point of the compass on 3.
Would you?
Just need to connect some dots.
Yeah.
Connect the 3 point to
Already did that one.
J. All right, so kind of like in a proof where you mentally do a step but forget to put it on paper here. Make sure you specify. Okay, so now back to Ethan. Now we need to.
Put one compass on 3, and then
Good. Put the point of the compass on 3.
open it less than 2.
Good. Open it somewhere so it fits inside too. But it's bigger is better, right? So if we open it really small, it's going to make it hard to do what we need to do. Open a little bit bigger here. Make an arc. So it goes all the way across the angle. Then keep the compass open the same amount.
And do it on the other ones.
Go where now?
On 2.
Good. Not right here. Not at the arc you left off on. At the 2 point. Make a nice sweeping arc. Then
On the 1 point.
at the 1 point. Now again, not the arc you just made, but at the 1 point, make a sweeping arc. Then we're going to need to
It does. Connect. Bisect. Bisect. Measure between that arc.
measure how big the arc at the bottom here is. Then now we're not going to the 2 or 1 points. Now we're actually going to the new arcs we made. Measure across here. And then this arc that we made here, measure across here. And then to finish, we'll connect those points of intersection back to where?
To the green line.
The 1 and the 2. And then connect these back to the 1
Oh,
and to the 2. And of course, when you do this, go all the way through the points. That would go up through the point, hit the line, and then we should have 3 equal segments. Questions on this? All right. Next construction that we worked on was Circumscribing a circle about a triangle. Circumscribing a circle about a triangle. So if you put it on your paper, go and draw a triangle. Don't make it enormous, but don't make it too small either. And if we want to circumscribe a circle about a triangle, Chris, what do we need to do?
Get the angle bisectors.
Angle bisectors. Well, those will intersect at a point called the incenter, but I want to circumscribe.
Perpendicular.
Perpendicular bisectors. Good. So kind of like with the bisecting the arc, right? Where you put the point of the compass, open more than half, make the arc above and below, connect the dots. We're going to do the same thing with this baseline here. Open more than half, arcs above and below. Will the circumcenter always fit inside the triangle, class? No. Remember, for a right triangle, the midpoint of the hypotenuse is where your perpendicular bisectors will meet up, where that circumcenter will be. And for an obtuse triangle, class, the circumcenter will fall outside the triangle. Now, my suggestion is once you've drawn one perpendicular bisector, rotate the paper so that a different side is down. Now, in my case, I can't do that, so I'm just going to have to kind of go sideways here and perpendicularly bisect another side. Do we need all three perpendicular bisectors?
You don't have to have it, but it helps.
Yeah, don't have to. If you've got time, a third one might help just to verify your point is correct. But what you can do too is just look at your perpendicular bisectors. Do they look like they bisect? Do they look like they're perpendicular? If so, then they're probably correct. Now, if you notice, that one doesn't look like it bisects, or that one doesn't look very perpendicular, your compass may have shifted. So, but anyway, once we've located this intersection point, this circumcenter, what do I do next?
What you do is you put your point of compass on the dot.
On the circumcenter?
And then you open it to one of the angles.
Good, one of the vertices of the triangle.
And then you go around.
Good, and then you just make a circle. So that it hits every vertex of the triangle. Questions on this construction? All right, now make a bigger triangle. Make a larger triangle now. And this time we want to inscribe a circle within this triangle. To inscribe a circle within the triangle, Chris kind of already got us started here, Jamie, but what do I need to do first?
Angle bisectors.
Angle bisectors this time. And here's where I really do recommend doing all three, just because by our experience we would all agree this one tends to be harder to get it right, doesn't it? So I would suggest bisecting all three angles. Locating again that, what's that point called where the angle bisectors are going to meet, class?
Incenter.
In the center. Does the incenter have to be on the inside of the triangle?
Yes.
Yeah, because the circle does. So of course the angles all have to meet, or the angle bisectors all have to meet at the very, or at the inside of the triangle. Again, technically, you're crunched for time. 2 will do it.
So you're saying this test is we're gonna need a lot, or we're gonna be short on time?
Most tests you'll want to, by our experience in geometry, because the questions require a little bit more thought oftentimes, may want to work quickly. You never, of course, would want to waste time by sitting there pondering a question that you're not sure of. You'd want to move on and come back to it, right? Always a good strategy tip. And my angle bisectors are, wow, right on. Okay, that's a good sign. So once we have our incenter, again, if they don't meet perfectly, kind of guesstimate a middle space here. But once you've got your incenter located, then what? Kendall?
From the point where all they go bisecting
The incenter.
you do a perpendicular bisector.
Perpendicular bisector. She said just one word too many, class. Just make a perpendicular, right? Because if to make a perpendicular, it won't necessarily bisect, but we need to make a perpendicular. Remember, that's that smiley face construction, right? We'll put the point of the compass there. Like Wazowski construction, I think someone called it.
Yes.
Cyclops construction, for those who are more literary among us and more
Yes.
well-read.
Yes.
It's not Cyclops.
He likes the Cyclops.
Percy Jackson.
Wasn't it Ulysses that tried to fight the Cyclops or something in the literature story, and he got captured, he and his men. The Cyclops were going to eat him, and the Cyclops had these enormous sheep they were taking care of, and so all the men strapped themselves to the underbellies of the sheep where the Cyclops couldn't find them, and when they took the sheep out to pasture, the men got away out of the cave they'd been holding. Anyway, something weird like that. It's been a long time since I read the story, but I'm getting a nod from Audrey, so I'm guessing this was this year, 10th grade literature?
Yes.
Last year, themes in literature, 9th grade, so it was a real long time ago. All right, which Genesis and Chris are like, okay, I'm in the clear. I wasn't here in 9th grade.
I'm over here like, what, big sheep?
What?
What's a big sheep?
Who was the guy that wrote that? Well, that wasn't like Homer or somebody, was it? Or was that, I don't know, it was a Greek mythological work. But anyway, all right, so we, once we've drawn this perpendicular, let's come back to Jamie now, because I got sidetracked talking about Cyclopses.
Cyclone?
Cyclo? Anyway,
Cyclone?
not clone. So Jamie, I've made my perpendicular, now what?
Now you measure the perpendicular with your compass and you draw the circle.
All right, moment of truth. My chalk has moved too far down.
That was
To be
anticlimactic.
usable, I know, very anticlimactic.
Nothing's more satisfying than when you don't see anything outside the line.
I know, I start drawing and nothing shows up on the
Yeah.
board except a smudge.
Yeah.
Like, well, that's obviously not going to work well. Let's see if we can-
It's a lie.
Mass murder.
Genocide.
Now we're going back to
Mass-
trisecting.
Back to trisecting.
Mass genocide.
I wouldn't heard Genesis. I like Genesis.
Genocide.
Alright, so let's see if we've got,
Barely.
Oh. Oh, come on.
oh, and it misses.
I
Alright, minus a point.
out-constructed the constructor.
Alright, questions on this? We'll give them a chance to do the chalkboard sometime,
Uh-oh.
not while we're recording.
Uh-oh.
Alright, let's go ahead and draw a circle on your paper now. Draw a circle on your paper. And go ahead and pick a point on the circle. Actually, we'll let Audrey pick where we want to put our point on the circle. Give me a clock position, Audrey. 3:47. Smart Alec. That was not necessarily my Audrey impression.
I'm about to say.
Pretty accurate.
11 o'clock. All right, so right about here. That was just my general nerd impression. That's the kind of answer a nerd would give. Audrey obviously didn't. She just said 11, but my inner nerd came out as I asked the question. I was like, if I were the stupid student being asked,
that how you
I would
talk
answer that way.
Is that how you talk to school?
No, not typically. All right, so we want to construct a tangent at this point. How many tangents can we draw at the point, class?
One.
Just one. So we want the tangent as a point. And Audrey, what do we do? Draw a radius, but extend it through the point. And then what? Good. Basically, we are constructing the perpendicular to the point, construction 4. So again, point on either side. Go to those points. Remember, open the compass a little bit more, or you know you're going to be able to complete it. And when you connect those dots, have our tangent. All right, questions on this? Now, I had a friend in school who, anytime he was asked a question, could be a smart aleck, was a smart aleck. So it wasn't I, of course. I was always a good student. All right, let's go ahead and draw another
Just like
circle.
me.
In case any of my teachers were watching. Comments are disabled, so they can't debunk it.
Mission Gas Special Edition Mythbusters.
But you can't have, you know how like, I like watching magic tricks and illusions and stuff, and like, so sometimes there will be a magic show or something, this other magician reacts to it, like breaks down, okay, this is how it was done, or this is my response to it. Anyway, get some other, former teacher reacts to Mr. Dodasky's YouTube video, which he claims, but they can't just leave comments. So, all right, anyway, we need to pick another clock position here, and Genesis.
3 o'clock.
3 o'clock. All right, so here's 3 o'clock. But we're not going to mark on 3 o'clock. We're going to go beyond 3 o'clock. A little, medium, or a lot?
Medium.
Medium. All right, so right about here, medium distance outside our circle. And Genesis, how do we construct not one but 2 tangents from this point?
You connect the dots.
Good. Start by connecting the dots.
And then
Yes.
I,
No, you. You were saying
you,
we all us folk. We all. Use guys. It's only if you're from New England.
us.
Audrey has family up in New England. Use guys.
Do the
Good. Perpendicular bisector. Really, we don't even care about the perpendicular bisector. All we really want, class, is the midpoint. But we need a perpendicular bisector to get it. So open the compass more than half, arc above, arc below. Other point, arc above, arc below. And connect los datos. Woo. And this line almost went tangent to the circle. If it did, it doesn't matter. We don't care. If it went inside the circle, we don't care. We don't care anything about that line except we care about the midpoint. That's the only part of the line we even care about. And what are we going to do next, Ethan?
Would you put the point of compass on the point and make a dot?
Put the point of the compass on the midpoint, and how much do I open the compass?
To the center of the.
Oh, toward the center of the circle, okay? So like that, that
Make
much.
it through the, make it through the circle.
Okay, so we measure that much and we make the arc go through the circle?
Yes, on both sides.
Okay, so all the way through, so there'll be, there we go, couple points there of intersection. And you don't even have to make the whole arc, as long as you get this measurement, mark it here, because these points, class, are the points of tangency. Now, what do I do to finish here, Jamie?
You connect the point outside the original point outside.
Good, this
the circle.
original point. Don't go to the midpoint, go to the original point, connect to the points of tangency. And I suppose, if you wanted to, you could draw a little alderon or something over here. Anyway, questions on sorry, that was kind of dark. What is it when I get to this end of the board? First there's EJ, now there's, the blowing up all. Anyway, questions on this? Questions on this?
He had a live out or whatever.
All right, questions. All right, obviously you'll have a couple of these constructions that we did, and then one unmemorized construction. And of course, we'll use a lot of the constructions we used, whether it be bisectors, copying angles, making perpendiculars, measuring lines, all these kind of things may be included in your unmemorized construction. Let's go and talk arcs and angles now. You can set your instruments aside, unless you, actually, go and keep the compass and straightedge out long enough to copy this picture. Let's go ahead and make a large circle, see if the compass can avoid it slipping here. Make a fairly large circle. And let's see, let's go ahead and name the center point O, because that's what we always do when we're boring. We'll go ahead and let me use the straight edge, make the picture look nicer. Go ahead and draw a diameter down through O. And let's call the diameter AB. And let's go ahead and make a chord from A to a point C. And let's make another chord from C don't make it perpendicular to AB or anything, and let's call this one CD. And if thou couldest, at point D, kind of guesstimate where your radius would be. Don't actually draw it, but guesstimate. And then try to draw a perpendicular. So basically what you're doing is you're getting a tangent point at D. Tangent line at D. Let's call the tangent TN. And then we'll tell you what, from T, let's connect all the way to B. So from T, let's connect all the way to B. So you have this picture here. We're going to label this point right here P, and we'll call this point here R. All right. So we have this little triangle arc right here, ARC, or it's car. Anyway, let's suppose, oh, and we need to name this point here as well, don't we? Let's call this point E. All right, so we've got several arcs here. We've got diameter, AB. Let's suppose we know that arc AE, I don't know, looks like it's about, let's just say 65 degrees. We've got arc BD, let's say appears to be, let's say 80 degrees. Let's say that arc BC appears to be 70 degrees. And let's see here. What angles do I want you to find? Let's find angle CAB. Let's find angle BPD. Let's find angle ETD. Let's find angle CDN. See angle EBA. And angle ARP. Take a few minutes to work on that, and we'll take a look at it together. What do I need to find first before I can find any of these angles, class? We don't start with angles. What do we start with?
Arcs.
The missing arcs. Yeah, so let's find arc DE and arc AC first of all. So how many were already doing that? How many needed the reminder? All right, go ahead and find those arcs if you haven't already. How big is arc AC, class? 110 degrees. Again, you've got this diameter here, so that gives you a 180 above the diameter. 110 and 70 gives you 180. How about arc DE? And you've got a 65 and 80. That leaves a little 35 degree window there below the diameter. All right. How many could go on both of those arcs? 110 and 35. Excellent. Go and find the angles now. How big is angle CAB, class?
It's 35.
35 degrees. What kind of angle is it? Inscribed angle equals half its arc. Obviously cuts off a 70-degree arc. Angle BPD, it doesn't have a special name, it's just inside a circle formed by a couple of chords. How would I find the measure of angle BPD, Quentin?
Half its arc and the opposite.
Half of its arc and its vertical angle's arc, right? The sum of the two. So its own arc obviously is how big, class? 80. How big is the vertical angle's arc, anyone? 175 degrees. So you're going to have to add the 175 and the 80 to get 255, right? And then take half of that to get
127.5.
127 and a half degrees. Or 127 degrees 30 minutes. Or 127.5 degrees. Any of those answers would suffice. How many had BPD correct? All right, questions from those who did not? All right, continue working. Some people already finished. Good. ETD. This is outside the circle. What kind of lines make up ETD, class? Well, one of them's a tangent, the other is a secant. Had it been two tangents, it would have been the same mental process, though, or had it been two secants, same mental process. Because anytime the angle's outside the circle, class, we need half the difference of the arcs. Now, the first arc that is cut off, class, is an arc of 35 degrees right here. How big is the next arc that's cut off? 80 degrees. So the difference here is, what is the difference? 45, half that difference, 22 and a half degrees, or 22 degrees, 30 minutes, or 22.5 degrees, any of those would suffice. All right, CDN. Formed by what kind of lines? Again, it doesn't have a cool name, but it's formed, class, by?
Tangent and tangent.
Tangent and a chord. Okay, angle formed by chord and tangent, class? Half its arc. Now, how big is its arc?
115.
It is 150 degrees. This entire arc is being cut off. So half the arc would be? 75 degrees. How many have 75 degrees? Excellent. All right, EBA. Here's EBA. What kind of angle is EBA, class? Inscribed angle equals? Half its arc. How big is its arc? 65. So the angle is going to be 32 and a half degrees, or 32 degrees 30 minutes, or 32.5 degrees. How many had that for EBA? And for ARP, this angle here, again, Genesis, is formed by intersecting chords, right? Now, one of the chords happens to be a diameter, but since it's not at the center, it's not a central angle, so this angle's got to equal... Good, now how big is its own arc? Got a full 100 degrees here. How about its vertical angle's arc? 70. So the sum, of course, would be 170, and half that sum, 85 degrees. How many had that for the last one, angle ARP? Questions at all on arcs and angles? Been a little while since we've done it. Feel like it's a skill that we have not lost.
Yep.
Okay, questions at all on this? All right, loci, as I mentioned in our last review, will be present. We reviewed all the fundamental loci already. Again, intersecting loci or compound loci, you would simply put a couple of them together. Again, think of all possibilities. So if I give you exact distances like 3 inches from this, or 2 inches from that, or equidistant from 5 inches apart, got to account for those distances. But if I don't tell you those distances, or I don't tell you where this point is, or where that line is, or what kind of angle we have, make sure we think of all possibilities. Think of crazy examples, right? If it's an angle, think of like a straight angle or reflex angle. If it's a couple of lines, think, well, what if they're really far apart? Or a couple of points, well, what if they're really far apart? Things like that. Try to think of those types of examples. And then pictures and proportions. Let's go ahead and drill over those one last time to make sure we're good to go, since that's some of the bigger points on the test. If I give you a picture that looks like this, where we've got a triangle with a line drawn that's parallel to one side. Let's call this triangle QRSTU. And if I told you that TU was parallel to QR, there are three proportions in words that go with the picture, class.
Bottom is top is bottom. That's the wrong one.
Bottom is to top is bottom is to top. Whole is to top is whole is to top. Whole is to bottom is whole is to bottom. So again, in letters then, you're thinking then, for instance, QT is to TS, as UR or RU is to US, and things like that. So if I told you that RS was 12 inches, if I told you that TS was 7 inches, if I told you that QS was 10 inches, and I was asking for RU, at your seats, solve. Did you label on your picture all the parts? That's going to be important. Now, the nice thing is on the test, you can draw directly on the picture. You don't have to copy a picture over. But definitely take the time to label directly on the picture. Which proportion of words do I want, Audrey? Good. You're looking at the side that has the X. That's this side. I've got a hole in the bottom. We want whole is to bottom is whole is to bottom. The problem is, well, I've got whole is to bottom here. I've only got whole is to top here. You can't do that. You have to do whole is to bottom again. So I need to find the bottom segment, class. 3. Now I can do whole is to bottom is whole is to bottom. How do I plug in the numbers, Audrey? And when we cross multiply and solve, we're going to get, class, 3.6. I don't like decimals, but it worked out evenly. I'll take it. I prefer 3 and 3/5. So again, what you do on the calculator there is when you get the 10x equals 36, instead of 36 divided by 10, 36 fraction 10, and it'll reduce it down to the 3 and 3/5. And since I had units here, in my answer I want units, I'll say 3 and 3/5 inches would be our answer there. Do we want any more practice with this picture, or do you feel like we've got the hang of it? Again, make sure you use the right proportion, put the correct pieces together. Now, kind of with this picture, another way in which you may see the problem asked, you may be asked, is the line parallel? You may not be told it's parallel, you may be asked to tell, is it parallel? For instance, if I gave you the following lengths, if I said that ST is 4 and QT is 3 and RS is 8 and RU is 6. Okay, is the line parallel? At your seats, find out. Is it or is it not parallel? right, how many say, Mr. Dasky, you are a liar, it is not parallel. All right, detentions for all of you for calling me a liar. How many say, Mr. Dasky, you're an honest man, it is parallel? Ethan wants to change his answer. All right, first thing you've got to do, label on the picture. Here's 4, here's 3, here's 8, here's 6. I can't make a proportion out of those numbers. I've got a bottom and top on one side, I've got a hole and bottom on the other. I either need to find the top over here, class, 7, or I need to find the top over, I need to find the hole over here, which is 7, or the top over here, which is 2. It's really your choice. And then you could try to say top or hole is to bottom as hole is to bottom. That's an 8, just doesn't look like it. Or you could try to say top is to bottom as top is to bottom. Or you could try to say hole is to top as hole is to top. And in every case, you keep coming up with a lie. So is it parallel? No, of course it's not. Questions on that? Again, the only way to know is to plug it in one of the valid true proportions. Of course, we had this picture, remember, where we had a whole bunch of parallel lines and a couple of transversals. And let's call these segments E, F, G, H, I, K. And let's suppose that we were given that F is, looks like about 4 inches. And suppose we said G was 7 inches. Suppose we knew that H was 1 inch. And we knew that K was, I don't know, looks like 9 inches. And I want you to find E and I. So find the vowels given the consonants. Ethan's like, huh? I'll Chloe explain it to you sometime. I'm kidding. Ethan's smart. He knows these things. I just like picking on Ethan. Shh, not so loud. What proportion do I need to set up here, Quentin? E is to who?
1. This 4 is to I, 7 is to I.
Okay, there we go. E is to H, is F is to I, is G is to K, but plugging in the values, yes, E is to 1, is 4 is to I, is 7 is to 9. And which one did you solve for first, E or I? I. So just, again, it's right here, just looks really easy. Cross multiply, solve, we get?
5 and 1 7.
5 and 1 7. And of course, we want to use inches since that was used here. And then when you solved, again, I wouldn't use the 5 and 1/7. For one thing, it's hard to plug into the calculator. Not impossible, obviously, but I'm lazy. And so I'm going to use these two here. And what do we end up getting for E's length, Chris?
I got a decimal.
Well, we don't want decimals. We want to use the fraction button so we can get a fraction here. Or, honestly, this one's easy enough. We can do without the calculator. Genesis? 7/9 inches is correct there. Did you get 0.7777777? Yeah, anytime you get a repeating decimal, it's a single digit, it's that many ninths. So 7/9 inches. Questions on this one? All right, next picture that we had involved an angle bisector in a triangle. Anytime there's an angle bisector in a triangle, class, in words, what proportion do we need to be thinking?
Side to side.
Segment is to segment, as side is to side. So we bisect an angle. Here's a segment is to another segment, as a side is to a side. Let's go ahead and call this L, M, N, O. And let's suppose that low is 6 inches. Let's suppose that lim is 14 inches. Let's suppose that lum is, let's find that one. And let's suppose that is 18 inches. Find lum. I had to make up hard numbers to get Quentin to get his calculator out. He's just too smart. He's been doing all these in his head, and now he's like, okay, I'll dig it out. Laziness prevails again. Obviously, the problem here with lum is, does lum actually go into the proportion anywhere, class? No. So on the picture, 6, 14, 18, and this is what I'm finding, but it doesn't fit in the proportion. Now you could call this x anyway. If you did, how would you have to represent mo? X minus 6. How many did that? How many said, nah, I'm going to call mo x, and I'm just going to remember that I don't care about x, I care about lum. How many went that approach? Either approach is fine. I think this makes the proportion easier. If you simply set it up, Ethan, so that
6 is to x, 14 is to 18.
right, and then you cross multiply, what is that, 120,
14x
180 equals 14x, then divided by the 14, you got x equals, or
7 and 5 seconds.
7 and 5 sevenths. Ew, that's disgusting.
Yeah.
And so we get 7 and 5
You
sevenths,
add those.
and add them together. Well, actually not too bad to add them.
13 and 5 seconds.
13 and 5 sevenths inches for lum. How many got that answer there? Now again, if you did the x minus 6, it just means you have to distribute, but once you get x, you're done. You found exactly what you want. You don't have to have that extra step of adding them, so there's some upside there. What if we had this picture, and we'll be done with this. We have a triangle with a side extended and an exterior angle bisected this time. Let's call the triangle Z, Y, X, extend to W, bisect out to V. In letters, again, here's your triangle, Z, Y, X. In letters, what's the proportion going to be here? Chris?
Segment, side to side.
Right, segment, side to side. That's in words. Now in letters, what's that look like?
VZ is to VY as ZX is to YX.
Perfect. And so if I knew that, I don't know, VZ is 10, XZ is 8, YZ is 12, and I wanted to find XY. Let's finish with this and we'll be done. Jamie, how do I plug the numbers in? Chris gave us the proportion. How do I plug in the numbers?
Is it 10 is to x plus 10?
Well,
Wait, no, would it be 22?
right, VY is here, and I know both parts of it, so that's just a 22 as,
Let's see. X, wait, no, 8 is 2x.
there we go. And we'll cross multiply, and what will we get, anyone? 17 and 3/5. I will take 17.6 since it ends clean in either of those answers, but I prefer the 17 and 3/5 answer. All right, make sure you study your terminology. Right, there's a lot of terminology. Make sure you study your properties. Make sure you study transformations. All that proportion stuff, again, is going to be the biggest points on the exam tomorrow. Make sure your notebooks are good to go as well. Have a wonderful rest of your day. You are dismissed.